Welcome back, students. In this video we're going to cover the study guide for Module 10, circles. We got a warm-up in the top here. So went over this in class today. Had a lot of folks absent. I know tomorrow is some sort of actually makeup test from today because of either the internet or Performance Matters being down. I think there's another test, and then also Wednesday there's SAT for juniors. So anyway, you guys may or may not be there. This is also the week before spring break. So anyway, I'm going to go through the study guide. So if you weren't there today, or you listening later and haven't taken the Module 10 test, this is what you want to watch. So, sorry. Didn't mean to take that long, just wanted to do some housekeeping. So, warm up. Number one, part A, complete the chart below. Alright, so name the following for the circle on the left. So we're going to start with center point. Well, center is in the center, duh. But, so this is point M. So the center point is M, and the circle to the left is circle. Sorry, this thing's a little too sharp. Circle M. So it's not part of the question, but I'm just trying to reiterate. That's the name of the circle. All right, so radius. So I'm going to do this. Let's see. So I don't want to just use, we see this is the diameter because it goes through the center point, but MB is a radius, but also is MA and MC. M is the center point, so the radius goes from the center point out to the circle. So any radius, radii, that's the plural, it's going to start with M. So if we had a MQ over here, it's also a radius because it goes from M to the edge of the circle. So diameter. Diameter is, it goes through the center point, it touches both sides of the circle. In this case, our diameter is AC. Okay, let's see. Chord. Chord touches both sides of the circle. You see here we've got dB. But AC is also a chord. It's the diameter, but it's a chord because it touches both sides. Alright, an arc. I'm just wanting us to name an arc. Just going to go right here. This is arc AB. Hopefully we can see that. Obviously BC is an arc, CD is an arc, DA is an arc, but we don't have to name them all. Central angle. Now this is formed by the center point, so our central angle here be AMB. Now, not to be confused with an inscribed angle, which touches the edge of the circle. So here we would have ADB. So don't get them confused. Central angle, let me just do this. Okay, so it touches, it goes to the midpoint, the center point, excuse me. Do I have a, let's do this. Oops. So, just like D, and then D, the inscribed angle touches the back of the circle. The central angle is in the middle of the circle. Center point. Okay, in part B to this warm-up, they ask us in the figure above, if AM is 17, then what is BM? Well, I had them I started them with M. They started with the edge of the circle. Either way, so AM is a radius. BM, well, that's also a radius. We know that all radii are congruent. So if this is 17, then this is 17. It would be 17, this would be 17, this would be 17, and of course both sides, you see both sides of the diameter because the radius half the diameter. Okay, moving on. Number 2. And I almost took this out of the review because this one was taken off the test, but I'm trying to make it as simple as I can. And this is just not one of those simple ones. So we have point J, point M, that goes with these circles. So the diameter of M is 72. Well, you see we're dealing with the radius, which is half of that. So this is the diameter, 72. This is the diameter for J is 58. Well, since the radius is one half of the, I can't write tonight, the diameter for M, the radius is 1/2 of 72, so we'll just do MR like that. It's 36, and then for J, it's half of 58, so JR, so Mr. and Junior here, is 29. Alright, we'll go to a different color here. Okay, so the diameter, I'm trying to do this in color, but not, so from M to K, we're going to say, so we'll do it, yeah, MK. Sorry guys, I forgot about the camera, how doesn't do this in the classroom, but MK is our radius there, so it's 36. So J to L is this guy, so just doing that. Now they're telling us that JK, so this portion is 9. And they want LM, which is this part. So if we have this portion of JL, so if we can find out what this is, we can subtract it from the radius of M. Just bear with me. So MK is made up of LM. That's what they want us to find, so we're going to call it X. Just put X above it. Plus LK. LK is what we're going to get down here. Okay, let's use this one. So JL, that's this radius, is made up of JK, which they tell us JK is 9, plus LK. LK is what we're looking for up here. Since we said LM will be X, we'll call LK Y. This is also a reminder, we never solve X and Y together. We get one of them, plug it in, and then do X. But anyway. Alright, so JL is 29. This is going to get messy. Well, we'll do the one here, and then we'll move over here to finish it. So, alright, so JL is 29. Jeez. Not doing great. Okay. 29. JK is 9. LK is Y. That's what we're looking for. We're going to subtract 9. I'm getting a different pencil. Ugh. Okay. Subtract 9. These cancel. 20 minus 9 is 20. And then we have Y. So Y equals 20. So this is 20. So now JL is made up of JK, which was 9, plus LK, which now is 20. So 20, and this is JK, and L and LK. Alright, so now we can plug 20 in here. So let's see. Goodness, okay. Alright, so MK was 36 plus LM, which is X, plus LK, which we know now is 20. Subtract 20, subtract 20. See that X equals 16, or LM. I know that gets dicey. I'm glad they took it off the test. I hope you guys follow that. It's a lot, and I'm sorry. Alright, bottom of the first page, number 3. Consider the figure below, and they want to know what the measure of arc AB is. Okay, so we learned in Module 10 that the angle, so we'll say angle D because that's what it is one half the arc. Well, we're looking for the arc. So the arc is 2 times, so let me just do this. So the arc is 1/2 of the angle, and then the angle, of course it's the measure, but the angle is 2 times, oh geez, this is terrible. The angle is 2 times the arc. No, I did that backwards. The arc is, yeah, God help. The arc is 2 times the angle. The angle is 1/2 the arc. So, the arc is 2 times the angle. So let's just scratch that out. So in this case, this is 43, so the measure of arc AB is 2 times the measure of angle D. That's 2 times 43, so the measure of arc AB, oops, is 86 degrees. Eraser stuff there. Okay, number 4. This time they want the angle, and they give us the arc. So the angle that's created by the arc that's created by this angle. That's what we were going for. So in that case, angle is half the arc, arc is double the angle. So for over here, what's the measure of angle WYX? And it's going to be 1/2 the measure of arc WX. So that's 1/2 of, this is 30. Half of 30, so the measure of angle WYX, half of 30 is 15 degrees. Okay. Hurry up, I'm going too slow. Okay, flipping over. Alright, page 2, number 5 at the top. So, we've got a survey. This circle graph shows the percentage of students who voted for each ice cream, and they asked them which was their favorite. So they're asking us what the measure of arc ED is. ED is chocolate. Chocolate was 33%. So degree. So they want, like, if this was a whole pizza, pie, whatever, we cut out this much, they want to know. So it's actually area is what we're looking for. No, I'm sorry, they want the degree, they want the arc measure. So for here, we know the whole thing is 360. So if we're trying to find out how much 33%, so for this circle, ED represents 33%, so it's 33%, which is also, just to help, 33% is also 0.33. this looks like 36 degrees, not 360. Oh my goodness, hold on. So 360 times 33%, or 0.33, we get 108.8 degrees. So all we're doing is multiplying whatever this percentage is by 360 to get that to the nearest degree, so 119. That's why I always tell you, what is it asking for? I'm ignoring my own rule. Alright. Number 6, what's the length of EF? And these are the equations that go with each of those chords. Now, they tell us that these arcs are congruent. Now, the thing about those arcs being congruent is it means that these chords are also congruent. So in this case, ED is congruent to FG. It's also equal to it. That's what congruent means. So ED is 2x plus 6, and it's equal to FG, that's 5x minus 9. Now they want FG, so we're gonna find x this way and then plug it in here. All right, 2x is my smaller, so I'm gonna subtract it from both sides. Those cancel. We got 6. 5x minus 2x is 3x minus 9. Okay, I'm gonna add the 9 both sides. Cancel out. 9 plus 5 is 15. It's equal to 3x. We divide both sides by 3, and x equals 5. Well, they want FG. The FG equals 5x minus 9. It's 5 times, let's do it this way, times 5 minus 9, that's 25. Minus 9, so FG equals 16. Okay. Alright, now, down here, number 7. So this one is, we didn't touch much on this in the module. We kind of touched more on it in Module 11, because Module 11 is a geometric measure, which is a lot of area and volume and stuff like that. So we're actually going to use area here. They want to know what the arc length for this is, and they want it to the nearest tenth, and we got to recall the arc length formula, which is, so this angle here is C. We would put theta in this case, but I'm going to put C here because we're dealing with C, but it's whatever C is divided by 360 multiplied by 2 times pi times the radius. Now recall this formula is also the area formula for a circle. So what we're really doing is we're multiplying this piece of the pi times the whole pi to get how much that piece is. So go switch here. So we have 45 over 360. Now notice they have 12 here. 12 is for AC. Well, they're both radius. That's a radii. So that's your radius. So down here we have 45 divided by 360 times 2 pi, and then this was 12. That's the radius. So we're going to use the calculator. So 45 divided by 360. So it's 1.25, and I think I wrote this in class 1.25 times. So now, let's see if I can make it show me both, or if I'm going to have to erase this out. So we're multiplying that by 2 times pi times the radius 12. Alright, so this is 75.39. We're going to round it to 75.4. I hit equal. Okay, yeah, so it didn't stay, but so we'll do it this way. So we'll say 2 times pi times the radius. So it gives us that times alright, so we get 9.42. We round that down So let's see, arc AB equals 75.4 units squared, because it is an area. Okay. Okay. Moving on. That was yes, page 3, number 9. Oops. Okay. Rearrange here. Sorry. Okay, number 9, top of page 3. What is the value of x? So x is over here. So these 2's go with the measure here. They're telling us that AB and CB are congruent. So, and if these chords are congruent, these arcs are congruent. Okay, so to find x, the whole thing's 360. We're going to subtract the 74 here from 360. That's going to give us this. Just a second, flip the page over here. Alright, so 360 minus 74 is 286. So that means from here all the way around, it's 286. Now, see, B splits this. This arc AB and this arc BC are congruent. So if we can cut this in half, we can find out what x is. So we divide this, so 286 divided by 2 is 143. So that makes x equal to 143. And over here, this guy's equal to 143. And then if you add 143, 143, and 74, you get 360. That's the whole circle. Alright, number 10. If the diameter is the diameter QS is perpendicular to chord TR, what all do we know about the circle? So let's see a couple of things here. And they kind of tell us some. So it's perpendicular, so we got a 90-degree angle. It's perpendicular bisector, so that means these two sides are congruent. So TP is equal to PR. Oh, there's the first one. And they show us that. So TP is equal to PR. Alright, so if these two chords, if these two are congruent, then these two are also cut in half by the diameter. So the chords are congruent. Let's use this. So that's TR and QR. So those, we know that. Alright, so next it's saying TQR and TSR are equal. Well, I don't know about you. First off, this is not in the middle, so this is way shorter or way smaller than that. So we're just gonna say no. No. Oh, sorry for the camera. Sorry. I know that other app is better, and this thing is just making me crazy. Hang on. Let's see if I can get it to hang on. Okay, sorry. I don't know. I hit the magic button. Alright, so we know that's not true. Alright, so what else? TR, so this whole thing is equal to 1/2 of PR. Okay, well, PR may be half of that, but TR isn't equal to half of PR, so that's a no-no. Alright, and last, PR, so this side is equal to 1/2 of this whole thing. That is absolutely true. So for this one, it's A, B, and E. Yeah, so PR is half this. Okay. Oops. See, now you see the magic. Okay, number 11, determine the values of each variable. Alright, so we got x's and y's, and I told you guys 100 times we can't find x and y in the same time. We have to find one, then the other. So we got a quadrilateral here. That's all we know. Well, we know that quadrilateral, that opposite sides are supplementary. That means that angle E plus angle A are equal to 180, and that angle V plus angle C are also equal to 180. So, opposite sides. So that's how we're going to plug this in. If you notice here, X and a number, Y and a number, they usually kind of set you up. You just have to remember, hopefully if you can't remember Y, you can remember that we can't do X and Y at the same time. That's what I'm hoping for. Alright, so angle E is 115, angle A is 2Y, and then we got 180 here. Well, we're going to subtract the 115 from both sides. It's going to leave 2Y equal to 65. We've got to divide both sides by 2. Sorry. Y is equal to 32.5. Over here. Alright, so over here V is 70, and C was X, and then 180. So subtract the 70 to get X alone. Alright, so here X equals 110, so short and sweet. Number 12, so flipping over. I think when this was originally done, these were colored in, but so opposite sides are congruent here. There's also, you notice Y here, X here, X here. That's why I think they were colored in, because I don't know. Anyway. Sorry, my daughter is calling me, but I cannot answer. Alright, so here it'd be angle O plus angle Q. It's hard to read, but that's angle Q. Those equal 180, and then R and P equal 180. Oops, equal 180. Sorry. Excuse me. Alright, so angle O, 2x. Angle Q, 2x plus 4. 4 always looks like a Y. Excuse me. Get some drink. Okay. Alright, so 2x plus 2x is 4x. And then we've got the plus 4, which we can just go ahead and subtract it. This cancels. 180 minus 4 is 174. Excuse me, I'm trying not to cough again. Excuse me. Alright, so divide both sides by 4. X equals 44. Excuse me. Sorry, I can't get to the pause button quick enough. Alright, so angle R, 3y plus 8, and then angle P is just y, 180. Let's go ahead and subtract the 8. That's 172. These cancel. We have a 3y plus a y, so we have 4y. Divide both sides by 4. And y equals 43. Okay. Excuse me. God, I'm sorry. This pollen is just killing me. Okay. So number 13. They want to find the measure of angle Q. So first we need to find X. So if this is the diameter, I'm trying to get it to focus back in. This is the diameter, and then this guy is going to be a 90-degree angle. This is your hypotenuse. Anyway, well, we know the whole triangle equals 180, and if that's 90, 180 minus 90 means these two guys are complementary, which means angle R plus angle Q equal 90. And then angle R is 2x minus 8. And angle Q is x plus 14. goodness. Alright. Negative 8 plus 14 is positive 6. So these two are gone. 2x plus x is 3x. So those are gone. Alright, now we're going to subtract 6 from both sides because we want x by himself. 90 minus 6 is 84. Divide both sides by 3. X equals 28. Sorry. I'm so sorry. So aggravating. Alright. So if this equals x, we want q. Angle q equals x plus 14. X in this case equals 28. So 28 plus 14 means that angle q is equal to 35 degrees. Well, there's the degree, but you guys get it. Alright, let's see. That page we're flipping over to page 1, 2. I thought we were on page 3. 1, 2, 3, 4. It's page 5, excuse me. I lost count because they're not stapled, and I'm just going as we go here. Let me just zoom out because I'm having a hard time getting this whole one. Oh my god. Yeah, here we go. Now we got the whole thing in there. Alright, number 14. Determine if segment AB is tangent to the circle. To the given circle, select all that apply. Alright, so in order for AB to be tangent, that would make it would mean that this would have to be a right angle. This would have to be a right angle. And yeah, this would have to be a right angle. Alright, so and if these are right triangles, that means a squared plus b squared is equal to c squared, right? So if we have this, then we have a check mark. You know, we're good. If no, then it's not a right triangle, and we don't. So we're gonna do this one on the calculator, okay? So if a squared plus b squared equals c squared, we have a check mark. So this being c. So 8 squared plus 15 squared equals 289. Now, we hit the square root. If we get 17, we have a check mark. If we don't, then we don't. So square root of 289, 17. So I say we have a check mark. We have one. So we'll just do this. How about that? Okay, let's see if we got the same thing here. Eight squared plus 12 squared equals. Alright, so if 208, well, we know 17 was not 208 a minute ago. You see, you hit the square root. We got 1442, so we have a no. Alright, so now let's do this one. 7 squared plus 24 squared equals, and I already know that 625, the square root of 625 is 25. So in this case, A and C were the answers. Alright, number 15. What is the radius of the circle? Let me just zoom back in now. Alright, so notice, you know, this is the radius, so from the middle point to the circle is x. That's why this is x. It's from here to here. Well, this line goes further than that. See, it goes out here, which they say is 8, and then of course this guy is 12. So we're going to use the Pythagorean theorem because this would be, let's see, we're going to use Pythagorean theorem, a squared plus b squared equals c squared, so we can solve for x. So again, a squared plus b squared equals c squared. So a squared is x squared. The b, that's x plus 8. See, this is x, that's 8. So c squared. I'm sorry, that's the c squared. This is the b squared. This is bigger. Sorry. Sorry, maybe that felt wrong. So your b squared is 12 squared, and then your c squared is x plus 8 squared. Alright, so x squared is x squared. 12 squared is 144. Now this gets a little complicated. I'll take you guys back to Algebra 1. This is the same as this. You know, this times this, or this times this. So this looks familiar. We got to use the FOIL method. Front, outer, inner, last. Excuse me. I'm not going to go through drawing and all the stuff. I'm just going to. The first is x. So x times x is x squared. Your inner outers is x and 8. So x times 8 is 8x. Your inners are x times 8, which is 8x, and then your last 8 times 8, which is 64. We combine these and make them 16x. So this equals this. I'm going to move it over here now. Okay, everybody with me? Cool. Alright, so I'm going to get rid of the x squared. I subtract it from both sides, and these guys are gone. So now we got, switch to red. So now we have 144 equals 16x plus 64. So let's subtract the 144, and then I'll take it up here. Actually, no, let's not subtract the 144. Let's subtract the 64, because it's a smaller number. Alright, subtract 64. These are gone. 144 minus 64 is 80. Okay, so now we have 80 equals 16x, and we'll bring it up here. So we can divide both sides by 16, and we can find out that x is equal to 5, so your radius is 5. Okay, bottom of this page. Sorry, I've lost count. And let's see. Okay, so find the perimeter of ABC. You see this is inscribed. That means that circle touches here, here, and here, and the way it comes out, this portion, these two sides are congruent. These two sides are congruent. And these two sides are congruent. So we can fill in the blanks. Green, 6. This is 6. Brown, this is 7. That's 7. Orange, 4. This is 4. So now the perimeter is just 4 plus 4 plus 7 plus 7 plus 6 plus 6. Which really have, this is 10. The outsides make 10. The middle makes 14. 10 plus 10 plus 14 is 34. Just don't ask. You can just use the calculator. I promise I'm right. I did, I think, tell first period today it was 36 because I misadded. So that's also out of all right. Okay, flip it over. Should be just about done. I think we have this. Yeah, we got this in the last page. So scooch it up. 17. Alright, so again, just like the last one, portions that stick out behind the circle are congruent. Now we have some whole amounts. We're going to have to play with the puzzle here to get what the brown here. And we'll start with, let's see, hold on. Excuse me, let's see. That's caught up here. Alright, so we know that the green is 7. Okay? So that's 7, and this is 7. Well, from here to here is 32, so this orange is going to be 32 minus 7. 32 minus 7, because this is 32, and we're subtracting out that 7. So 32 minus 7 is 25, so that makes the orange 25. I'll write it up here. Well, that makes this orange 25. Okay, so we got the greens, we got the oranges. Well, now the brown, so if here to here is 40, and the orange is 25, 40 minus 25 is 15, so that makes the brown 15, both sides of it. Alright, so now we have everything, and now we can find the perimeter. Well, they said find BX. So BX is 15 plus 7, which is 22. Alright, the perimeter is going to be BX plus the 40 side plus the 32. We add those all together and we get 94. Okay. Number 18. It wants to find y. Alright, so when we have inscribed angles, I'm going to write this here. So when the angles are inside the circle, so when the angle is 1/2 of these two arcs. If you have a situation where it's like this, the angle's out here, then your arcs are going to be, so your angle will be 1/2 of, let me put arc B minus arc A. So when it's outside, when the angles are inside, we add these two arcs and take half of it to get the angle. These angles are vertical, so either side. This angle created here, you see it splits the circle into a big arc and a small arc, or a major and a minor. We subtract the minor from the major, and that gives us that angle. Well, we subtract them, then we take half of it, or we divide it by 2. So over here, my angle L, would have been equal to 1/2 of arc GH plus arc JK. KJ, excuse me. So we know the angle is 132. Got half. GH is 178, and KJ is Y. Okay? I'm going to multiply this both sides by 2 because I just don't really care for that fraction. 2 times 132 is 264, and I still have 178 plus y over here. Subtract 178 from both sides. I'm going to just scooch it over here. Y equals 86. Alright, number 19, slightly different. Now, alright, so I'm just going to call this A. So, and I'm going to call this side B. Okay, so these two are vertical angles. So A and B would be congruent. X, and we'll call this guy Y down here. X and Y would be congruent. Well, notice that A and B are on the same line. These are a vertical pair. A linear pair, excuse me. Linear pair are supplementary. Okay, so what we're going to have to do, we're going to use these arcs to find these guys, because they'll be the same, and then we're just going to subtract this from 180 to get X. So, hold on, because A plus X equals 180, because they're a linear pair. X is going to equal 180 minus A. And then A, so angle A equals 1/2 of this arc plus this arc. Alright, 45 and 85 make 130. 1/2 of that is 65. So angle A equals 65. Now let me scooch down because we have a number bank here. And 65 is in that, but wait a minute, X, they want X. This was A. Remember, X equals 180 minus A. So 180 minus 65 makes X equal 115 degrees, which is also a choice and the correct one. Alright, flip it over to the last page. Yes. Alright, number 20, top of the page. These are level 1, level 2 questions. Not on the test, but very important to know. So, standard equation of a circle given the center and the radius. So here's the center, here's the radius. We found out in module 10 this formula is x minus h squared plus y minus k squared is equal to the radius squared. Now, when we write it, it would be the radius squared. So, like for this one, let me just go ahead and do this because the radius is 7. 7 squared is 49. So this is going to be equal to 49 because it's radius squared. Okay. Now the center is your h and your k. Don't ask me why, it just is. So if it's x minus h is x minus 5 squared plus y minus negative 2. Well, minus negative 2, it would be x plus 2. So this would be the answer to A. Now for B, so again, this is r squared. 2 squared is 4. This is my h, this is my k. X minus h, or x minus negative 1, is x plus 1. Y minus k, k is 4. So there's the second one. Well, I say it's a level 1, level 2. I'm not real sure, but it's not going to get us a 3 or higher on the EOC. So just use this info for down here for a level 3 question. Number 21. Write the equation of the circle given the center that passes through a given point. So obviously from the center to any point on the circle makes you a radius. And we need radius squared here. So to get the radius, we're going to use the distance formula. This is on your reference sheet, but I'm going to tell you anyway. Make sure you don't keep it in your pocket. Your center is always going to be your x1, y1. Your other points, your x2, y2. Alright, so below here, my x's are negative 4 minus 3. My y's are 10 minus 5. Alright, so negative 4 minus 3 is negative 7. 5 minus 10 minus 5 is 5. Alright, so we'll scooch over here. Negative 7, anything squared is positive, so negative 7 squared is 49, and then 5 squared is 25. You add those together, you get the square root of 74. So our radius is the square root of negative 74. I'm sorry, the square root of 74. I don't know what I was saying. So this squared, so the square root of 74 squared is 74. Because you just take the box off. So here's your 74. Now, you have our center, so x minus h, so x minus 3, y minus k, y minus 5. That was just that simple. We just needed to know the distance formula. Alright, number 22, and this is the end of this, let me just scooch out a little bit. Okay, this is the end of the review, module 10. Sorry for all the camera stuff, it's ridiculous. So, we got a circle inscribed in a square, PQRS, on the coordinate plane. The equation of the circle is x minus 8, y minus 7 equals 16. What are the values of a, b, c, d? Alright, so before we get that, this is r squared. So the square root of 16 is 4. So the radius is 4. That's important. So to get a, we're going to take x minus r. B is y minus r. C is x plus r. And D is y plus r. And you're like, well, what is all this? Okay, so your x coordinate is going to be this here, the center. That's your x from your center. I know we called it h, and it's still h, but it's going to be plugged in as x. So x is 8, y is 7. X is 8, y is 7. We got pluses here, we got minuses here. R is our radius, so 4. Now, very easy. 8 minus 4 is 4. So A is 4. 7 minus 4 is 3. So B is 3. C is 8 plus 4, which is 12. And D is 7 plus 4, which is 11. So there's your A, B, C, D. I don't know where they get it. That's just how we solve it. That's it for this video. If you guys have any questions, let me know. Until next time, have a good night.